Cool. So welcome everyone. Today we are going to talk about a very interesting topic, something that actually I do dive into almost every other day. More recently, where I work on search systems, so it's one of our kind of an important topic overall to build better search systems, right? And this is how Netflix has built its own um, search system, query facet mapping model that they are using, which is we'll go and dive into a bit deep into it as we go, and the idea behind the system and how it came to be, and essentially how we actually use now Netflix. We can kind of see its effect. Without further ado, I'll just dive into it. And yeah, so I think as we know, search relevance and search systems overall, as we're used to kind of trying to ask and kind of get the question answered, or get the relevant output, we are used to a better search system, a search system that serves a purpose. Primarily, Google is something that vastly is used. So we're going to talk about like critical role of search functionality, and in terms of streaming, in specifically in streaming services, something that you would want to watch. They kind of Netflix offers extensive libraries of movies, TV shows, documentaries, a lot of it, like vast amount of content. So how to kind of find the relevant content that is for you, and make sure that your queries are able to like convert it to a relevant content that you would want to watch, and not something that you're forced to kind of look and make an effort for it. We'll dive into it, like how Netflix is building its own search system, and how using the relevancy aspect of it. And yeah, it's very important for user satisfaction. Um, the Netflix search system helps locate specific titles, explore new content, delve into like different genres of content, discover different actors' work that your for example Jackie Chan. You would just type in Jackie Chan and you get Jackie Chan movies, even if it's not part of the title, for example. So all of this is on the surface, it looks, of course, super simple based on what you're typing, but it has a lot of things going on under it. So that is fundamentally what we're going to talk about, which is the query facet mapping at Netflix, and that's the model. That's fundamentally a model, not a technology. Primarily is being used at Netflix for finding highly relevant output for the queries that we type. Right. So when we go into Netflix, on Netflix bar search bar, when we type things, it's basically the sorry, just give me a second. Yeah, so it's basically the query, the relevant output from the query that you get, right? Like if you type in One Punch or something, that you get One Punch Man as the output, as well as other animes, right? So that's something that we'll dive into how it does it. But before that, I think it's very important for us to kind of get the fundamentals right, um, and um, and kind of identify what exactly those fundamental aspects of search systems are, right? And it's not necessarily what Netflix uses or anything like that, but it's primarily one of the core aspects of search systems, information retrieval systems, which is term frequency and inverse document frequency, largely used across, like I would say, almost all search systems. I would say, and even Google would be using some parts of like maybe a modular version of it, but using inverse document frequency and term frequency as a fundamental model behind SEO ranking and SEO stuff that they provide. So term frequency and TF-IDF, what does it mean? Like term frequency is like essentially it reflects the importance of a word within a document. So in a simple term, if Netflix term appears 3 times in a document with 100 words, the term frequency for Netflix would be 3%, right? So it's like 0.03. That's the term frequency. It's super simple formula. There's nothing special with it. And the inverse document frequency, this is the other side of the things, where it kind of adjusts for the words commonality across multiple documents and not within the same document to again normalize the relevancy of that term. So formula for IDF, it's a bit complicated, but it's not so much, I would say. It's like just a logarithmic of a total number of documents divided by the number of documents containing that term. You can go ahead and look for it. Like, again, I won't dive into it much deeper. If you want to kind of understand the underpinnings of the formula, go ahead and read about it more. But this is something that is fundamental for a lot of search systems. In fact, right now, when I work on one of the search systems at my own company, Get Your Guide, we do use TF-IDF, some parts of it as well. So I'll just give you like a brief example so that it's easier to understand and capture what TF-IDF mean. So in this, like you can see 3 documents. The first document contains Naruto anime multiple times. And the term frequency for that is, as you can see, for Naruto, it's 3 in the first document. And for the term frequency for anime in the first document, as you say, is 2. But the inverse document frequency, again, that's the across, it's like a normalization across the term, across documents, sorry. So for Naruto, it's like 1 out of 1, which is essentially it's less frequent across documents, but anime it's more frequent across multiple documents. So the relevancy would depend on, again, the formula kind of depends on multiplication of it, and there's like some form of coefficient in there, but primarily it uses a combination of both of these values to kind of give an output, a mathematical number output that provides what the relevancy of that term across the data that we have, or you have, or anyone, any data set that you might have. So jumping onto the next kind of fundamental topic about this queries and understanding how query is broken down. And this is again relevant to the topic at hand right now. And this is just more of fundamental, and then we'll go into how Netflix is using these fundamental topics, aspects of fundamental topics, and then using these topics to cover their cases, the problem that they are solving. And so n-gram is basically like a continuous sequence of n items. Like it's super simple. It's like 3 words. It's 3 gram, right? So I give an example. So it's n-grams are used to model the like probability of sequence in a text. So if you have if you build for, like, if you have an index of n-grams, for example, if you build I want, and then that's a bigram, right? And that's like a two word n-gram, which then you can kind of build the data set for those 2 word n-gram as I want, and then I want ice cream, I want to watch football, I want and I want to go outside and play, like these all things. So I want is like a fundamental aspect of a bigram index, or a bigram data that you will have, data set that you would have. And then each of these multiple options that I gave, there is a prediction done based on the existing frequency of those outputs that has matched, right? So as I mentioned, like I want ice cream is most frequent things people search on Google, for example. Then for the bigram index, it would have I want, and then ice cream as the next term has a higher probability of being matched, right? So it's essentially it's several important use cases. It's in text analysis, natural language processing. LLMs essentially use n-grams as well for prediction, and like that's a fundamental data storage system as well. Like by analyzing sequence of words and like frequency, as I mentioned, you can kind of use that to multiple other variants of use cases. And also another aspect that we in fact want to talk about is autocomplete and autosuggest, right? So when you type in and then there is a prediction output in the search bar itself, or the output that you see wherever you're typing, this is particularly used in autocomplete as well, right, in grams. Now, moving on to now the specific topic that at hand, which is Netflix's Netflix's use cases around query and how they have built a query text. One aspect of Netflix is facets, and what facets. I want to kind of give a brief definition introduction to what facets is in case of Netflix. So as you can see, Netflix queries, and I've also given the output from the white paper that they've published. The query itself is broken down into real time basis, of course, broken down into multiple areas of classes, right? And that classes can be a collection. So the query can map to a collection like anime movies or anime shows, etc., or specific videos where it could be One Punch Man or Naruto or like something else that is highly relevant for that query, or Animal Kingdom or Planet Earth that is a bit less relevant to the text query but more relevant to the output. So and or talent where you could have some actor named with a prefix anime, or like some parts of the name would contain anime, right? So, or anim, sorry, and then that would be carried on as another class. So the facets are essentially, um, and with Netflix, and you might have seen with Netflix, it's something that you might have seen is that it also, when you type in something that's not available with your Netflix subscription or within the area that you are, it still would provide some relevant results, right? Like if you type in French, it might not give you French because they do not provide that in that region or location, but they do however try to match it with some sitcom based shows like Big Bang Theory or something else that is a bit relevant to what Friends show is, and that's relevancy capture is something that is interesting to kind of understand, and we'll go into it as we go into the deep in the session. But to understand what it is, it's like we need to understand that facets are talent, video, and collection. These three are the facets that Netflix kind of built. On top of it, it is in catalog stuff and out of catalog stuff, right? So in catalog means they have it. Friends is there for that region, or Friends is not there. That's out of catalog. Or our collection anime. There are no anime shows on Netflix for the region that you have, so it's out of catalog collection, right? So yeah, this is something that we need to understand before then moving on. Um, so now, like, think before again diving into query facet mapping, it's important to understand the concept of member engagement in Netflix search. Member engagement refers to like it's how users interact with entities that are lexically similar to the queries they fire, right? So as I mentioned and earlier, is like when you type in something, if you click on it, that's an engagement from Netflix's perspective, right? And if you click on it further, and if you actually start watching it, there's another aspect of engagement. And these, and again, before we move to query facet mapping, which this is one of the parts of query facet mapping, where one of the big factors where your query might not be lexically relevant, but produces something that is relevant from the user's perspective, from the region's perspective, from your cookies that you have seen, or from your history, etc. So Netflix section, as you have seen on the UI end, is divided into two parts: the video gallery section, which kind of shows the exact videos that potentially match, right? And the suggestion section, where the suggestions are usually specific videos or collections or talents or clickable links that you can further explore. So I'll give you like an example before. So if you see over here, on the slide, you can see one of the screenshots that I've posted. This is my own local relevant, like actual screenshot that I've taken. And if I type in anim, this is one of our very popular movies, Animal, in India, that's why it's kind of showing. But if you type in yourself anim, and you might be seeing some different results based on, again, the relevancy aspect, based on your region, based on your history, based on etc. It's multiple things, right? So, and then as you see, anim also considers Rick and Morty because it has some aspects of not anime or animal, but it has animation, right? So that's these kind of things. But Rick and Morty also is highly relevant as a animation series, animated series, right? So because like that's one of a very, very popular series. on Netflix. So this is these just kind of give a brief example. And so you can see like in the top, on the top side, you can see there are suggestions, animated movies, and those are collections, or they could be out of catalog collections or in catalog collections if you want to explore further. But if you are able to find the things relevant to you directly on the video side, on the video catalog, you can click on it, and that's the engagement score being increased for that particular query, and the relevant output or the video that you've selected, right? Or the entity essentially. So entities that are not lexically similar, but not also not that are lexically similar but not engaged with, are also not considered in the QFM system. So it means that like there would be some entities that match exactly anim, but since they are not relevant or they have a low engagement score, let's say like people never watch it, there's like 10 out of 1 million customers that Netflix has only watch that, they would probably not be showing it up as well. So it's very important to kind of, for Netflix perspective, to build this engagement scoring logic and kind of build as a feedback loop into their system, the QFM system that again we're going to talk about it, which is kind of these are the fundamental aspects of it. So yeah, each entity that is lexically similar to the query and also relevant to the query is matched. Relevancy in terms of engagement, I mean. The other aspect of it is like query expansion. So example, I said like anim is a prefix of animal, anima, animal, anime. So engagement from these queries, engagement as in if I click on animal stuff or anime or anything like that. And again, I'm giving this one example. Of course, it doesn't need to be like only this particular example. There's like other examples that you can always try and look and try it out for yourself, because it's like everyone has, I would assume, access to Netflix search. So you can see like all of this is attributed back to the query. An engagement score from this attributed back to the query anim. So whenever you type in anim and then there is let's say a relevant result that you've engaged with, then that is attributed back to the query that was typed, which is anim, and that kind of to increase the accuracy and like ensure smooth facet determination as members, as like members or customers of Netflix type more characters, right? So Netflix implements a simple like query expansion method, and engagement from a query is attributed to the prefix of the query. And for instance, as I mentioned, like anim type would kind of be attributed back to the engagement of anim output would be attributed back to the anim prefix. All right. All of this again, like these are fundamental aspects of the system that's being built. Now the other aspect of it is lexical similarity. Now, as I said, like there's an engagement score, of course, but there is also relevant query that you type that you would want to match, right, as well. And this aspect is also quite important, and along with the engagement score or the customer engagement or member engagement score, as I mentioned earlier. So for this lexical similarity, and when we talked about TF-IDF, right, TF-IDF, it works. It's one of the primary foundation for information retrieval systems, and it's pretty popular. Pretty much some are used almost everywhere in information retrieval. But in this case specifically, TF-IDF might not be ideal because for short titles or partial matches, because like for an example, orange is the new black, a query might be ORA or new B, which are partial matches. And because of this, TF-IDF might not produce a good output because it considers across all the data as well, across all the video titles and collection titles that Netflix has. And that's why Netflix built its own more of a different style of mathematical model, which is n-gram query to entity match, NQM in short. And it's an alternative to TF-IDF for short title like document match that they provide, right? So it's specifically designed for as like short title documents, and kind of combines, and itself is broken down into three key measures, which is percent match, arrangement, and quality. And we'll go into what each of this internals of NQM means. So it's important to know that TF-IDF, well, it's very much relevant to a lot of search systems, and it's very important. However, it doesn't work for all the use cases where it depending on the use case of the business itself, right, and of what the business wants. In some cases, business would not want a non-relevant lexical to be matched, and that's primarily important for the customers. In this case, customers do want to watch something, but they can also jump onto something else. It's not primarily like a Amazon like search system where what you want is what you get, kind of a thing. Right? So expanding onto the NQEM model, and some bits of pieces of screenshots from the white paper that I've added just to kind of it's because it's like a lot of information in this, just to kind of consolidate all the information, and it kind of combines three aspects of engrams, right? Percent match, arrangement, and quality, and each of the aspect will go into each of the aspects. And I've kind of shown an example with anime, which is what the primary example in the paper is as well. And if you see, a lot of irrelevant matches in the catalog video is also there on top, and a lot of in collection match that is relevant is part of the output as well, which is the lexical match, right? So it's very important. Like going on to the percent match, the first component of NQM score is basically measures the percentage of each term that matches against the given entity on the n-gram length, right? So again, for example, anim and the entity anime, the percent match output essentially is super simple. It's 80%, right? It's 4 out of 5. Versus, let's say, animal, it would be 66%, 66, 67%, right? So so that's the percent match output. The arrangement, which considers the arrangement of the match. So this includes attributes like, and it kind of, again, arrangement is broken down into other attributes, as you can see on the screen as well. It goes into starkness, orderness, and tightness, right? So for example, again, with the query anim, the entity anime, the match starts from the beginning, so it has a very high starkness. But if the query anime matching with anime would have a low tightness due to the space, right? And the query like only the AI and ME kind of part matching with anime would have low orderness due to the reverse order. So if it's like MEANI, like MEANI as an example, so not anime, MEANI as you type in, would be matching to anime, but it has a low orderness due to the reverse order of like the broken n-gram values, right? And third component is quality, which evaluates the quality of each matching token using flags such as partial, synonym, and mapped. For instance, if the query is animated T, the only part of TV matches animated TV shows, so it has a partial flag. If the query is animated television, television matches TV as a synonym, right? So for Japanese query, kana characters might map to kanji characters in the entity, accounting for ASCII folding and all the aspects of text stemming and phonetic mapping that we have. So these kind of aspects also important with each language. For example, with Al Capone in Spanish, it would be matching. It would match higher relevant items over there, versus when you type a Spanish term in English, it will try to match higher relevant shows directly, which matches the term, right? So it's these kind of aspects are also very important when trying to build the quality attributes and the arrangement attributes, because it differs from languages to languages, is what I'm. So now all these two aspects that we mentioned, the member engagement and the QEM, right? So these two aspects are kind of combined into the QFM model. And the step, like these are like, and also it's not combined, like I said, linearly or something. It has a more complicated system overall. And the first step of QFM model is to determine the relevance of the entities at the entity level. This is done by the blending function and the formula as given on screen. The blending function, like it's a non-linear function. They do not have a exact function being defined yet, like on the paper, but you can see like it's a function that is on the it combines non-linearly combines the query aspect as well as the entity. So and the sorry, it combines non-linearly the engagement score as well as the NQEM score. And then, like as example, query anim and the two entities, anime and animal kingdom. The lexical score for anime might be high because anime matches closely with anime. However, if animal kingdom has a higher, let's say, engagement score due to people using it more, like interacting with it more, then the blending function would adjust the relevance output, like the RQE output, um, accordingly, right? So yeah, this is why it's not a linear combination, but it's more of a non-linearity aspect to the function. The confidence score, that's the next part of it, and this is a bit like a interesting aspect of it. So the next step is to kind of convert the normalized relevance score. So like the scores are generated and they are normalized, like it's the total sum of basically the score, all the output of each entity versus the query is one, right? And the next step is to convert this into a confidence score. And this confidence score is like cumulative sum of normalized relevance score. So it's like over all entities where across which scores the confidence score is like a cumulative sum, and then it kind of has a threshold over it. So if it kind of goes beyond, it goes beyond the threshold, only then it allows to match. So this is very important because for broad queries, the relevance score may spread across many entities, right? So while for very specific queries, only specific entities are matched. So the confidence scores kind of helps systematically disregard low relevant entities by setting a threshold, typically some value that you would have, and the most relevant entity always has like a confidence score of 1. So each entity will have a confidence score and a threshold. So it's like if you have a list of items, some of the items might not make it to the output because the confidence score for these entity is less than the threshold that's been defined, right? So for example, with broad query horror, when you type horror, many relevant entities like horror movies, scary movies, and thrillers, the relevance scores are spread out, right? Because for each entities that we have to find, like from a movie's point of view, it would be like very much spread out, considering it's a kind of a genre-based query, right? So confidence score helps in this case quite significantly and only allows for more relevant activity, more relevant entities. For specific queries like Squid GA or something that you type, Squid Games has a very high relevance score. So the confidence scores helps ensure that these entities are always prioritized for these specific entities. So this confidence score kind of normalizes across all the previous score that we talked about, and like the entity relevance score that we have. And the Facet score, this is the final, like again, the combination of the above two. So final step is aggregating the entity level relevance scores. Again, the entity level relevance scores is combination of engagement score as well as lexical score. Within each facet to kind of obtain the facet level scoring for each query context and the facet. So facets, as I mentioned earlier, and just to kind of reference it back, facets are over here. It is in catalog collection, in catalog video, in catalog talent, and out of catalog collection, out of catalog video, and out of catalog talent. These are the facets. So the relevant score I was talking about is around these facets. The formula is like I've kind of given it on the screen. And there's a delta function, like a Kronecker delta function, which is 1 when the entity belongs to a facet, or 0 otherwise. So if the facet is, let's say, video, for example, and like the entity that was potentially matched before is like, let's say the facet is a video, which is One Punch Man, and the entity matching is horror or something, or the collection, I mean, is horror movies, then the delta score function is 0. So that's not considered as a part of like the overall summation that we have this year. So it kind of quantifies how likely a query belongs to a facet, like 6 facets that we've seen, and identifies most relevant entities within each facet, right? So another example is like for the query anim, the facet score might aggregate the relevant scores of entities like anime, which is a collection, animated movies, which is also a collection, and anime series, which could be again One Punch Man or anything like that, which is a video. So kind of facet score helps determine that the query anim is most likely related to IC collection facet, specifically the anime collection, right? Um, and not specifically to a video, because animes can be multiple shows. Uh, Hopefully a lot of things. So yeah, hopefully it's something that we are able to capture and understand. But like, of course, I'll reference the paper and you can go and read it. But like, just this is kind of gives us a kind of brief understanding of how Netflix does it, and then from a detailed point of view, of course, you can go and read the paper. So yeah, as like, just to kind of recap, there are two fundamental scores for QFM, that is the member relevance score and the engagement score. Now just think about the engagement score being tied to the feedback loop, right? Like people engaging. Like, just think about it. When Netflix started, there would be no engagement scores for each entity because nobody has engaged with anything. Like, just assume from theoretical point of view. So that's how the engagement score is generated. NQM score is more theoretical, right? It's lexical score that's bringing on the n-gram values. And then there's the blending function, which kind of combines non-linearly again the relevance score and the NQM score. And there is confidence score. Of course, there's normalization that happens. There's confidence score, which is not a part of the same, but it's another kind of a thing that kind of captures the query against each entity and how confident this query with each entity mapping happens. And it does it over like it's a cumulative sum over each entities that's being matched. And then so this is like a serial out by the way serial process, as you can think, like as you can see. And then there's the final facet score, which again combines all of these previously thing items and against each facet and produces like a final output, which is where the relevancy score is generated. So the next thing is essentially how would think about it from a perspective of rolling this out as a production service or productionization of this, right? Like, yes, the theoretically a lot of things have a theoretical basis, but we need to also kind of evaluate how it works, right, in production. And what the evaluation method was that for QFM was like 44K queries annotated manually by SMEs, all right, for across languages that Netflix provides, which is I think 30 languages or something, over 30 languages. And the objective was to compare QFM's video facet detection against the annotation of like people who try to annotate like how which query should match. So this is more of a as it's like a manual training process kind of a situation where you would want to kind of annotate and label things more relevant to each queries that people have fired, and then based on that attribute those things and compare it against the QFM model and see how much better or worse it performs, right? So the performance, as you can see on the screen, was super impressive. It's 95% accuracy. However, just like a quick note, it's important that the predicted facet score decreases. If the predicted facet score decreases, the accuracy decreases as well, which simple means that the model is working pretty well. And that if the model does not produce a good output, then the lib or the output that for the query that's being produced is also not relevant for the users. So it's like the confidence output of from QFM kind of decreases with the decrease in accuracy as well. So like it's the other way of kind of the accuracy is going, right? Now the other aspect is more accurate matching systems, right? Like from a perspective of query processing service that they have, there's also named entity recognition from the query. So once that name entity recognition is captured, what relevant aspect would be kind of, there would be, it's a dictionary based approach, and uses a shallow parser. But essentially, once it kind of extracts the entity out of the query, you would want to kind of also check, and you would kind of capture the filters out of it. But the limitations from this is, it doesn't use behavioral signals, it doesn't use engagement scoring, it doesn't use relevancy matches, all of it, right? So this is pretty much the limitation of it, and you can see it from like when you try to match it as lexically as possible. I don't think Netflix allows you to kind of try this out, but just think about it. When you see the output from Netflix's perspective, if it were matching lexically only, you wouldn't see a lot of as output that you would want to see. Like, for example, when you try to search for best anime, it might just search for that particular text with best with anime as a filter, because it has extracted anime as our one of our from the name entity recognition model that they have, right? So this is the limitation, and that's why QFM is integration with QPS is important, and something that they saw, and it was an improvement, and they saw in the facet recognition across several languages. So, for example, the query "what you" was correctly mapped to "I know what you did last summer" by the QFM enhanced QPS, whereas QPS alone would have failed to kind of make that connection, because now it's trying to extract an entity out of "what you" and not trying to just kind of lexically match. Also does the engagement match. It doesn't do all of that. So a lot of the signals from the data set that Netflix has, QPS will just ignore, and it's essentially not going to produce relevant results from Netflix's product perspective, right? And from how users actually engage with Netflix. So yeah, that's the comparison that was done for QPS against the QPS query processing service. And what's the benefits of QFM? The integration of QFM has led to several benefits for Netflix, including improved facet recognition, as I said, for accuracy and combining lexical and behavioral signals. The results were basically better search relevance and organization of the data, enhancing the overall experience for the customers. Additionally, QFM has also shown improved performance across multiple languages, which is something that's, of course, Netflix caters to as well. So, like there's of course future work that is also highlighted in the paper. They plan to explore different machine learning techniques and not just like a mathematical blending function, right? That is used in QFM. Also developing methods for handling new facets and like unseen queries. So if you again see, like if the queries isn't unseen, it might not also provide a good relevant scores, because since there is no data for the relevant scores for that query, right? So they also need kind of also want to incorporate QFM into like a main relevance ranking model, which is for like a multitask learning setup that would also improve the effectiveness of the model itself. So it's like once you build something, you want to push kind of also push it to its limits, and you want to use a more aspects of a better function, better combining functionalities, blending functions non-linearly. That is possible now with more sophisticated machine learning models, right? So that's something that is some looking ahead kind of a thing, right? So potential applications. One potential application of QFM is in the context, of course, of search results. By using the query context and facet scores like as an additional signals, the search ranking model can also prioritize entities that are relevant to the certain facets. So going into even in the collection itself, like when you go into the collection using the existing queries as well, it could kind of build the existing collection in a way that provides relevant entities, top relevant entities for those collections as well. And also better search result organization by structuring the results to what what the user intends. This is particularly useful for queries with multiple intents, right? So, for example, the query Irish, right, for let's say, could also be looking for Irishman, the movie, and or exploring the genre of Irish movies. So QFM kind of can guide again with the relevant scores, and like a bit sophisticated n-gram lexical match to into cohesive groups and like with some relevancy output results, right? Also, user trust. I think this is one of the aspects of the applications or use cases for QFM can kind of enhance user trust by detecting unavailable content, right? So one of the aspects of QFM is not just in catalog stuff, but out of catalog things that it tries to match and kind of get output from. So QFM can detect the intent for Game of Thrones or Friends, even if Game of Thrones or Friends is not available in the catalog, right? For that region or for whatever reason Netflix doesn't provide, which I really dislike Netflix for, but when I'm traveling. So this is really important. Like I think these signals cater to the business directly. It's just super important. Um, so another aspect is like outlier detection. So by using lexical and behavioral signals, QFM can effectively detect and mitigate outlier entities in search results, right? So reduces biases. Like as I mentioned, the confidence scores can kind of cater out or take out things that are not relevant, and would reduce because it's not engaged or because it's not relevant. It would remove those items even if there is some biases attached to those queries for relevance, and provides a better relevant ranking. Um, that's the potential applications. And now the summary, as I mentioned, it's you can of course go ahead and read, but just summarizing, the QFM model is essentially a combination of lexical match, confidence scoring logic for the entities for each facet, and the engagement data that Netflix uses. So essentially, engagement data could also be multivariable, right? So each engagement can be click through rate, could be like time, relevant time that was gone into after clicking, right, into watching it. So people might have clicked, but if it just people just move off from that video after, let's say, 2 minutes into the video, then the engagement score definitely would be reduced as well, right? Um, so that's something that we would also not want to see as those results that I click and I just don't want to watch, right? So these are very important signals as well. And the evaluation aspect is like the QFM achieves high accuracy for queries with high facet scores. So with 95% correctness, so accuracy, which is super impressive. And for this is considering for each keystroke, right? It's trying to match within the each keystroke the whole query against each entities and all the relevant entities that's being filtered into the result set, right? Um, also, as I mentioned, applications, there are multiple applications like outlier detection, better ranking, better collection ranking, better collection uh, build system, like better building, like the pre-processing of collection itself. As I mentioned, Irish movies would have the collection of Irish movies would be better when Irish movies query capture the intent of the user. So if Irish movie shows some irrelevant results, then the it doesn't need to be part of the collection of Irish movies because yeah, just there is no people using it, no one's using it, right? Um, and the future work, as I mentioned, like it's there would be, of course, this doesn't mean like this is the final step. There would be more relevant functions being used for blending within the for the blending function that they have between the relevance scores, relevance function, and the lexical function, the NQEM. So that would improve the adaptability of the QFM model. And this is again, this all of this is not related to a technology that they have built, but more related to the models that allows over any technology. You could use it like a dictionary based ngram look on a in-memory data structure that you would want to use, uh, or something else, or like a, let's say, Elasticsearch, or something else for autocomplete, auto suggest. But you can, on top of that, you can leverage the QFM model to produce more relevant results. And like this is more of um, a generic model that you can apply to different types of technologies. Doesn't need to be, there's no one technology over here, right? So that's important to know. And yeah, hopefully people are still watching. um, Thank you so much. Any questions? Happy to hear. If I don't know the answer, of course I can, happy to connect with you later as well, and I can share my email link. Thank you so much, Khalid. Feel free to ask for the slides if you want. Of course, you can also, I can also share the link to uh, the paper. Actually, let me do that. That's so. I think this is very interesting paper. Just feel free to read it out. Thank you so much, by the way, guys. And just feel free to read the paper. If you're working on search systems or something, there's it's a unsolved problem yet. Like, there's no one solution. It depends on the use case, and depends on and the problem, and problem at hand, and the um, business side. So as I said, this is something very much relevant to me, and that's why I was very much interested going into it. So if it's relevant for you, just go ahead and read about it, and try to see if you can apply some parts of it to your own search systems, and improve your search system. So, yep. If no questions, feel free to reach out for the slides if you want. But if no questions, we can stop here. We can have 10, 12 minutes for ourselves. And yeah, thank you so much. Bye bye.